Hey guys, welcome to another video of our Stellar tutorial series. In this video, we are going to be talking about the Stellar Consensus Protocol. In the previous video, we talked about Lumen. We dissected what Lumen is. We talked about the history of Lumen from how it was initially 100 billion total supply to now 50 billion total supply, and the events and that transpired in between those two values and the two figures. And we talked about what you use Lumen to pay for. We talked about rent. We talked about how it is used in smart contract for rent, and for how Lumen is also used for transaction fees, and also as a minimum balance that must exist in every Stellar account. So basically, we talked about accounts, we talked about rent, we talked about transaction fees, Lumen in general as a native currency of Stellar, and why we needed to have a native currency for Stellar. So we talked about all of those things in the last videos. And in this video, we are going to be talking about Stellar Consensus Protocol. So I'm going to be talking about Stellar Consensus Protocol. And over the course of this series, right, the tutorial series, I've mentioned the consensus protocol over and over and over again. So I've explained what it is, how it works, but I'm just going to go over it again since we are now talking about this in detail. So for the consensus protocol, from the first video, we mentioned that a blockchain needs to have a set of rules that govern all the nodes, right? So all the computers that function as nodes on the blockchain need to be governed by a set of rules. The rules that govern these nodes, these computers on the blockchain network, ensures that each of the nodes reaches the same state. It ensures that each of the nodes, when they update the ledger, has to update the ledger in the same way, and the current state, the current value that is updated, the current state of the ledger being updated, has to be the same for every single node that make up the blockchain network. And such that when whatever node picks up a transaction and executes it, every other node that confirms that transaction and that re-executes that transaction also needs to have the same value and the same state. So what governs those nodes, since they are distributed across different places, they are distributed and decentralized, is the consensus protocol. And for Stellar blockchain, for the Stellar network, the Stellar consensus protocol makes use of a consensus mechanism known as the proof of agreement. Other blockchains, like I mentioned earlier, also like the Bitcoin and Ethereum, uses the proof of work consensus mechanism and the proof of stake consensus mechanism. But for Stellar, it makes use of the proof of agreement. And what is the proof of agreement? The proof of agreement is simply a way of relying on the agreement of trusted nodes. So it's basically a way of a node saying that I trust all of these nodes, and whatever their judgment is, I agree with them. And this allows for openness in the network. It allows for decentralized control, because now all the nodes decide what happens in the network, and it allows for faster time to finality also on the network. So we are going to be talking about all of this, but looking at this, we've spoken about what consensus protocol is all about. It's a set of rules that govern all the nodes of the blockchain to ensure that they come to the same state, and to ensure that they have the same state after every transaction and after every processing. So, and to ensure that they update the ledger in the same way, and that the result of the ledger after the update stays the same. Yes. So now talking about that, we already understand that the Stellar Consensus Protocol also makes use of the proof of agreement, right? And the proof of agreement is based on the Federated Byzantine agreement also. So that's, you can see it as a Federated Byzantine agreement or the proof of agreement consensus mechanisms. And basically what it means is that a node agree with other nodes and trust them to reach consensus. So that's basically what it means. So now, how does the proof of agreement work, right? So I'm going to be showing this using a diagram. So the proof of agreement works in this way. So say we have these nodes, these are nodes, right? All of these are nodes. You can call them validators, you can call them validator nodes, or you can call them nodes. They are basically all nodes. So what means that all of these need to decide on what other nodes to trust. That's basically the idea. So every single node here, node A, node B, node C, node D, node E, needs to agree on what other nodes they trust. They are all connected. Yes, the P2P network connection is a P2P interconnection between all the nodes, but they need to agree as to which node do I want to trust. So the process of that agreement and the process of reaching that agreement is what we refer to as the proof of agreement consensus mechanism, different from other blockchains form of agreement. So now, why do we choose this, and what are the benefits? Like I said earlier, it allows for open network, like it allows for the open network membership basically, so that everybody can participate and become part of the node, and also allows for decentralization, like a whole lot of decentralized control happens because there's no single person that has to vote to make this happen. Every one of the nodes have the control to choose which node they want to trust. That's basically that. And now there are different components, right? Let me call this components um of this SCP, of the Stellar Consensus Protocol. So there are different, let me increase this a bit, and this. So let's look at the components of the Stellar Protocol, right? So these are like the components. So we've talked about this. Let me move this a bit up there. So looking at the components now, so we've talked about, we understand now that the proof of agreement, this is how it works. This node have to agree to which set of nodes it wants to trust between B, C, D, and E. And B also needs to agree as to which node it chooses to trust. Do I want to trust A and C, or A, D, E, C, or just C and D alone? Now, each of these nodes needs to agree on what other nodes that is connected to them they want to trust. And that is basically the way proof of agreement works. Now, looking at the component of the consensus protocol, now let's dissect what makes them what they are, right? What is that specific thing? What makes it, what makes up the consensus protocol, and why does it work the way it works? So now looking at it this way, the first component that we have is called the quorum set. Now, the quorum set in this case, using the same diagram, is going to be more explanatory, so just a way of understanding it better. So we have the quorum set in this case, and what does this quorum set mean? So given that A, as node A from here, decides that my quorum set is B, C, and D. Now, what does the quorum set means that? It means that I choose B, C, and D, that's node B, node C, and node D, as trusted nodes. I trust them as the nodes that also exist in this on the network, right? So I trust these nodes, so they can also be part of the consensus mechanism. So I'm trusting these three nodes. That's node A talking now, that I trust node B, node C, and node D. So as part of these nodes that are trusted by node A, it becomes the quorum set for node A, right? And now, how does this now work now? Already, so assume that node A already has these three sets, these three nodes as its own quorum set. There needs to be a threshold also as to how many of these sets that is chosen will be required for it to be valid. Required for the other consensus to be valid, will be required to say that, okay, for this particular number of nodes from my quorum set, I want this to so a number to be the valid number, right? So now how does that mean? It has to be the valid number of nodes, right, that can proceed with the consensus. That's the meaning. So now, aside from the quorum set, there needs to be something called the threshold. So what does the threshold mean? So given that the quorum set for node A and node B, C, and D, so that's this diagram, right? If the threshold equals to 2, then the following is valid for stellar proof of agreement consensus mechanism. It means that B and C, if B and C agree on this, it is valid. If B and D agrees, it is valid. If C and D agrees, it is valid. Simply because the threshold for the validity of this node with regards to consensus, with regards to the agreement of the processing of a transaction, has to be minimum of 2. Now, because the threshold is 2, minimum of 2 of these nodes must agree for there to be consensus. Minimum of 2 of any of these nodes in the quorum set needs to agree. And that's basically what this is talking about. So if there were more than this, let's say the threshold is 3 at this point, then that means B, C, and D must agree for there to be a valid consensus for node A. So that's the way it works basically. So now looking at this now, threshold simply means the minimum number of nodes that exist in a quorum set, the minimum number of nodes that exist in a quorum set that must agree to reach consensus. That's basically what the threshold is. And the quorum set is the set of nodes that are chosen by every other node as the trusted nodes. So given that this is understandable now, so now let's look at the next one, which is the quorum slices. We understand what the quorum set is. We understand what the threshold is. Now let's look at quorum slices. Now, the quorum slices are the slices that are gotten from the quorum slices, from the quorum set rather, using the threshold. So you have a threshold of 2, for instance, and you have a quorum set of 3 or 4 nodes. As long as the threshold is valid, the threshold requirement is met, and you have the minimum of 2 or minimum of the number of the threshold met, the nodes that are part of that set of the quorum set that are valid based on the threshold are the quorum slices. So in this case, in this example, whereby we have a threshold of 2 and a quorum set of 3 nodes, then BC, BD, or CD are all valid quorum slices. And that's basically what we refer to as quorum slices in this part. So those are the basic 3 components of the Stellar Consensus Protocol, excuse me. And we have them as, just to reiterate, we have them as the quorum sets. We have the second as, we have the first one as the quorum set. We have the second as the threshold. Then we have the third as the quorum slices. Now, all of these make up the components of the Stellar Consensus Protocol, because everything that happens within the protocol depends on these 3 things. So the quorum set must be must first be gotten by every single node. That's as part of the trusted nodes of that node. Then there must be a threshold for that node to ensure that, yes, so there must be a quorum slice also that matches the threshold from the quorum set. So having those 3 things in mind and in check, yes, now you can now see that, yes, whatever node of these quorum slices, all of these quorum slices now, whatever they agree upon is valid, and the transaction can now proceed. And so basically what it means is that a combination of 2 nodes in the quorum that agree is valid. A combination of whatever nodes, whatever threshold of nodes in the quorum set that agree is valid. So that means if B and C, in this example, if B and C agree, there's a valid consensus. If B and D agree, is a valid consensus. C and D agrees is a valid consensus. So the agreement of any of the consensus that matches the threshold of the quorum set is valid. And that's basically what we refer to as the proof of agreement consensus mechanism. So that's basically why, that's one of the reasons why we consider this as more efficient, it is faster, it is scalable, right? And that's basically how it works, because you can reduce the quorum set, you can increase the quorum set whatever size you want, and reduce it to whatever size you want. Given that they agree, then the transaction is said to be valid without any intermediary. They work on their own terms, based on the agreement, based on the code written in the protocol, based on the rules set by the protocol, right? That everything works hand in hand. And that's basically what the proof of agreement is. That is for the Stellar protocol, the Stellar Consensus Protocol. And that's that for this video. Hope you've learned something from this video about the Stellar Consensus Protocol. Thank you very much for watching. See you in the next video.